First process we're going to look at is the dissolution of the benzene into the water. So it's dissolving out of the gasoline into the water. It's the dissolution and solubility of it. For the next several videos, we're going to use this where is the benzene problem. So the setup is we have contaminated zone here, 10 by 10 by 10 meters. We have information on the soil, porosity, bulk density, the organic content of the soil, which we'll need. And then inside the pore space here, we have water, air, and NAPL. 35% of our total volume is pore volume, but that pore volume has those three phases in there. So we represent those with the saturation. 15% of that pore space is air, 2% is NAPL, non-aqueous phase liquids. So that must mean that 83% is water. So we have a saturation of water of 0.83. Remember, the saturations add up to 1. The specific yield and specific retention add up to the porosity, but the saturations are the fraction of that porosity, and so those fractions add up to 1. We have information on benzene that we'll need for our other properties, information on the non-aqueous phase liquid, gasoline in this case, and then the measured benzene concentration in water. So if I want to know the mass of benzene in the water in this box, I need the volume of water times the concentration of benzene in the water. So the volume of the water is the total volume of the box, which is 1,000 cubic meters, right? 10 by 10 by 10 is 1,000 cubic meters times the porosity, 0.35. So our pore volume is 350 cubic meters. And of that, 83% is filled with water, 0.83. So that gives us a water volume of 290.5 cubic meters. We don't have that many significant digits, but I'll keep the digits for now. So the mass of benzene in the water in this contaminated area is the volume of water we have. You see that up here, times the concentration of benzene in the water. So we have 290.5 cubic meters times the concentration of benzene in the water is 12 milligrams per liter. And then if I convert units, I might as well write them here. It's 1,000 liters per cubic meter. And then, so now we have, volume cancels out, we have milligrams, probably want this in kilograms. So it's 1,000,000 milligrams per kilogram. I'll go ahead and write it in two steps here. We have 1,000 milligrams gives us 1 gram, and 1,000 grams gives us 1 kilogram. Multiply that out. That equals 3.5. I'll write a couple digits, 3.49 kilograms. And that's the benzene in the water. We're going to have it in other places. We're going to have it in the air and on the soil and in the NAPL. A couple of notes here on the dissolution or solubility of benzene. What if you don't have the concentration of benzene in water? We just know that's in contact with gasoline-free product or residual product. So that's actual gasoline, either floating in there, we can get it out, or stuck in the little, between the little sand grains. Well, the solubility of benzene in water is about 1,800 milligrams per liter. So if it's at its solubility, well, we just get 1,800 milligrams per liter in water, right? You never see water solubilities or water concentrations close to 1,800 milligrams per liter at a gasoline site. The reason you don't is described by Raoult's law. So Raoult's law says the water solubility of a component in organic liquid. So we have a bunch of components in the organic liquid. Benzene is about 0.5 to 2% in an organic liquid. The water solubility of that component, benzene, is the solubility of the chemical, 1,800 milligrams per liter, times its mole fraction in the organic liquid. So benzene is typically about 0.5 to 2% of gasoline. And for general range, I'm not going to make a distinction between mole, mass, or volume fraction. I'm just going to say it's 1%-ish. So the solubility of benzene in water is actually 0.01 its fraction of the NAPL, the gasoline, times 1,800 milligrams per liter, which is 18 milligrams per liter. So that's pretty typical of a well that has floating gasoline on it or is exposed to drops of gasoline stuck in the soil. Another note is that it actually takes time to dissolve and diffuse out of it. So it's not instantly at its equilibrium concentration. A few more notes on dissolution. Let's say we leak 25 gallons of gasoline and say it has 2% benzene. That doesn't sound like that much, a big leak, 25 gallons. Well, if I take the mass of benzene in there, that 25 gallons, I'll convert it to liters, 3.8 liters per gallon. The density of that is about 0.74, typical 0.74 specific gravity, or 0.74 kilogram per liter density. So this would be the density of the gasoline, or the density of benzene, times 0.2 fraction. That comes out to 1.4 kilograms. That still doesn't sound like that much. That's what, like 3 pounds? Let's say that I have that 3 pounds, 1.4 kilograms of benzene in the water. So that's 1.4 kilograms. And I'm going to try to dissolve it out by pumping water through there. So as I said, I'm going to get about 10 milligrams per liter coming out. Might get 18 or something, but 10 is a pretty good number. So if I take 1.4 kilograms, convert units 10 to the 6 milligrams per kilogram, divided by 10 milligrams per liter, that's 141,000 liters, or about 37,000 gallons. So that doesn't sound like that much, 25 gallons, and only a little of that's benzene, 1.4 kilograms of benzene, but it's going to take me 37,000 gallons to pump that out of there. So just pumping water through these sites with high organic contamination in it is not very effective. By the way, this 10 milligrams per liter assumes equilibrium, which is not close to being true. Once you get the easy stuff dissolved out, it's going to take a longer time to get it dissolved out. Another little look at that number. The maximum contaminant level for benzene is 5 micrograms per liter, parts per billion. With that 1.4 kilograms, if that dissolves, spreads out so that it's down to 5 micrograms per liter, how much water is that it's spread out in? So if I take 1.4 kilograms times unit conversion 10 to the 9th micrograms per kilogram, divided by 5 micrograms per liter, that's 3.7 times 10 to the 8th liters that are contaminated with that 1.4 kilograms of benzene, contaminated to the MCL, or that's 370 million gallons. To come back to our where is the benzene problem, for 12 milligrams per liter in our source zone of 10 by 10 by 10 meters, it turns out that's 3.5 kilograms of benzene in the water. So we'll look at the concentrations and masses in the other phases now.